Moments ago, I left off discussing the definition of chemistry for our chemistry course, and we identified the idea of matter, the study of matter, anything that has mass and takes up space. And now I want to take a look at properties of matter, and that is where we'll pick up right here. And looking ahead, we've got four key ideas: qualitative, quantitative properties, and physical and chemical properties. And we'll start with those physical properties and chemical properties of matter. So physical properties. And I am going to cut one corner. Hopefully this will work out well for us. And for our properties of matter, this idea, we're dealing with characteristics, right? So I'm not going to include that in every single definition down there. When we're talking about properties, we're talking about characteristics. And these physical properties are characteristics that can be observed without changing the identity of a sample. All right, so these may be observed without changing the identity of a sample, and I'll abbreviate without changing the identity of a sample. And I think that this is, right off the bat, kind of unintuitive because you're not used to your observations changing things. And so if you were to look at this marker that I wrote with here, it's an orange marker. And our identification as this color being orange doesn't change its identity as an orange marker. Or we can say that this metal is shiny or it's smooth, things like texture. It has a certain amount of mass. These are all properties we can observe without changing the identity of the sample. So let's give some examples of physical properties. We said color, right? Shape, mass, the amount of space it occupies, we mentioned that, volume, texture, etc. All right? Now, in contrast to our physical properties, we have to look at chemical properties. I'm trying to choose a color wisely here. I would hope that looking at the physical properties definition, where we have this idea you may observe them without changing the identity of the sample, the opposite of that would be you change the identity when observing, right? So for a chemical property, these are characteristics that, when observed, change the identity of a sample. All right, and I don't think that that should necessarily sound too intuitive because you're not used to things changing when you observe them. So I'm going to do a common example that I use, and hopefully I don't light my phone/camera on fire here. But how do you know if something burns? And the answer is, if it is flammable, as in the case of this piece of paper here, if it is flammable, it will burn, and when I'm done, it's something else, all right? So let's see how much closer I can get this. Paper does burn. We've made that observation now, and when it's done, it's not paper anymore. So what is the chemical property we're dealing with there? If we talk about flammability, if you want to know if something is flammable, in testing that flammability, if it is flammable, its identity changes. We'll have to deal with a little bit of smoke here. It's like visiting the restrooms at school. Although smoking is passé now, everybody vapes. So chemical properties, something like flammability, right? And ability to decompose. All these other things which really relate back to two different things that we'll study much farther down the line, which is replacement reactions and oxidation reduction reactions. But flammability, we could say ability to oxidize. And another way we could say that, a common example of oxidation would be something like rusting. All right? If you want to know if a piece of iron will rust, you leave it out in the rain and it rusts. And when you're done, you don't have iron on the outside, at least, anymore. You have rust, right? Iron oxide that's there. It's not iron anymore. So it has changed identity in your determination if it can oxidize, if it can rust, right? ability to be reduced. So I'm just going to say ability to be reduced, right? And then you could make some other examples that are more specific to certain reactions. Like you could say reactivity with water. Does it react with water? All right, and hopefully at some level you're saying to yourselves like, well, do things react with water? Yeah, it turns out there's a bunch of things, and when we get into chemical reaction types and things like that, we'll talk more about those specifically. Both chemical and physical properties can be broken down in terms of being qualitative or quantitative, so I think it's worth it if we take a moment to discuss those terms. So qualitative properties, and again, if we were in a classroom setting, I would do some brainstorming to come up with ideas, and a lot of people will say qualitative ideas, qualitative properties, characteristics, right, that describe the quality of something. And in fact, that's not like super off base. But we need the comparison to our quantitative properties maybe to make it clearer. So what is a quantitative property? And again, if we're going to look at quality as part of that qualitative definition, then quantity must be part of that quantitative definition. And then we can break things down a little clearer. If you're talking about the quantity, you're talking about how much, and how much is something you can measure. So a quantitative property is some measurable property, right? And another way we might say that, it is numerical in nature, right? It's got numbers. So then what would qualitative properties be? They would have to be things that are not numerically measurable, right? So not directly measurable. Right? And so we would say they are non-numerical. And if we look at some examples of these things, what would be an example of something that is qualitative? Well, if we jump back and look at these properties here, color could be qualitative, right? In general, you might say something's green or something's blue, so that could be something that is qualitative. Shape, you could say something is round or something is rectangular or spherical. Those are all shape information. Mass, you might say something's heavy or something's light or something like that. Volume, you could say, oh, that's huge or that's very tiny. Texture, you could say smooth, and all of those things. So just for example, those physical properties or chemical properties, you could say, yes, something is flammable. But in turn, very often we can come up with quantitative versions of those. If you're in graphic design or computers or whatever, colors for a computer actually have numbers, right? RGB coordinates, red, green, blue. And so there are numbers that go with specific colors. You can give the dimensions of a shape and you could get quantitative versions of that. Mass, you could give a specific mass like 2 kilograms or something, right? Volume, 2 liters. Texture, there are actually, if you look at things like sandpaper, there are what are called grit ratings for how rough they are. So again, a lot of qualitative things you can describe without numbers, but when you're talking about making measurements, you're going to need some numbers to do that. And that's what's going to lead us to our quantities, and that'll be our big vocabulary term of interest in a little bit. We have 2 more types of properties that we're going to discuss for matter. I've run out of room on this sheet, and I don't want to start a new sheet for 2 vocabulary terms, so I'm just going to recycle the back of one of these sheets. We don't need that much room. So we're again continuing this discussion, properties, which we indicated was a way to describe characteristics, right? And this brings up an interesting pair of terms that aren't as intuitive as you think once you see them, and the first of which is intensive properties. And then I'm going to write the other one already, and that is extensive properties. And usually in class, I'll brainstorm a bit and discuss the idea of etymologically from how these words look, what could we determine. And intensive, a lot of people think internal. Extensive, a lot of people think external, which isn't directly how we need to interpret these terms. But if we look at it more philosophically, intensive properties are very inherent. I mean, they're, in engineering, we would call these material properties. Right? And they are inherent. That means they are there regardless. So intensive properties are things that are part of the nature of these substances. These properties are there regardless of external factors, whereas extensive properties depend on some external factors. So let's get our explicit definitions for these. What is an intensive property? Well, the external factor of interest to us here is matter, the amount of matter. Specifically, an intensive property is a characteristic that does not depend on the amount of matter present. It does not depend on the amount of matter present. And again, abbreviation amount. So let's get our definition of extensive properties written down, and then we'll jump back and list some examples. Just based on the fact that this does not depend, then this extensive property, following that same idea, must depend on the amount of matter present. So these are characteristics that do depend on the amount of matter present. And I don't know that this distinction is super clear without examples. What are some of the properties we looked at before that depend on the amount of matter present, and what are some things that don't depend on the amount of matter present? Well, the color of something, does that depend on the amount of matter present? Like, does this marker have to be this size to be green? Well, no, it doesn't. Does flammability depend on the amount of matter present? So we looked at this example of the paper burning earlier, and the answer is paper is flammable regardless of how much you have. And so those two things would be intensive. If you look at something like mass, does mass depend on the amount of matter you have? Well, yes, by definition, the more matter you have, the more mass you'll have. The more matter you have, the higher your volume. Something like texture, though, is independent of the amount of matter present, so that would be intensive. So if we look at some of these properties, and I just noticed this one off the page, because I'm a professional with my recycling skills. All right, so intensive properties, we just said might be things like color or texture. And I'll even go so far as to say, rather than looking at specific chemical properties, we will say generally chemical properties. Those ones we had looked at previously, like ability to oxidize, or we had said for iron that's rusting, ability to be reduced, or reactivity with water. These are all things that are material properties independent of the amount of them that you have. So what are some extensive properties? Well, we gave a couple examples. If they do depend on the amount of matter present, if mass is a measure of the amount of matter in a sample, well then mass has to be extensive. All right, other things that might be of interest, we said volume. Oops. Sorry about that. Length. If you want to measure the length of something, it's certainly going to depend on how much there is. And also, I want to mention, if you have mass and volume combined, if you're taking two extensive properties, sometimes those can become intensive. So mass over volume is density, right? Now we've discussed these different ways we can describe properties of matter, intensive and extensive, qualitative and quantitative, physical and chemical, and we need to talk a little bit about changes in matter. And the reason for that is our original definition of chemistry, which dealt with the properties of matter. We just handled that. Matter, we defined anything that has mass and takes up space, and now we need to handle those changes.